Good morning, everyone. I'd like to show how to compute the t-test and z-test using the SPSS version 23, or maybe in your gadget, it's version 17 or version 24. But in my case, I'm using version 23. So first, you are going to open your SPSS file. This file that I'm going to share is actually in your file also. If you remember, we have the data on sex, civil status, so forth and so on, up to performance rating. So these are actually the data that have been encoded in your gadget. So first, let's look up into a problem given in such a way that we can use t-test or z-test. So both t-test and z-test can be used if you are comparing two groups. You are comparing significant difference between two groups. And it is understood that the data are collected from a sample, and that the sample is actually drawn at random. For t-test, our n is less than or equal to 30. And for z-test, our n is greater than 30. But other books would say that for t-test, it's n less than 30, and for z-test, n is greater than or equal to 30. So that's a variation between the number of sample members or sample sizes. And that we assume that the data are normally distributed. And we also assume that the groups are independent to each other. So if the groups are independent, then, for example, we have group A and group B, then these two have different members in terms of the sample size. The sample found in group A are totally different from the samples in group B. So in this particular example, let's look at into this problem. So just jot this down when you watch this video. Is there a significant difference between the ages of the respondents when grouped according to sex? Is there a significant difference of the ages of the respondents when grouped according to sex? So I repeat, is there a significant difference of the ages of the respondents when grouped according to sex? So according to the steps that I discussed last time, first we state the null hypothesis and then the alternative hypothesis. So state the null and then state the alternative hypothesis. So if you're going to state the null, you're going to say there is no significant difference of the ages of the respondents when grouped according to sex. There is no significant difference of the ages of the respondents when grouped according to sex. Our HA, our alternative hypothesis, there is a significant difference of the ages of the respondents when grouped according to sex. Again, our alternative hypothesis, there is a significant difference of the ages of the respondents when grouped according to sex. So next step is to set alpha. So in this case, we assume that our alpha is 0.05. So our level of significance or significance level is 0.05. Next is to do the calculation. So we're going to do the calculation. So I'd like you to look at into this presentation. Just hold on for a moment. I'm going to have this. Okay, just for a moment. Okay, so go to analyze. So go to analyze and then go to compare means. And once you are in the compare means, you go to independent sample t-test. Independent sample t-test. So click done. And I'm going to reset. So our grouping variable is sex because we have been grouped according to sex as stated in the problem. So we have here sex will go to grouping variables. And then we have age as our test variable. So age as our test variable. And then we have to define sex. Now click on sex and then you can define the groups. So our coding for sex, we have 1 and 2. 1 for male and then 2 for female. So write it there. So 1 for male and 2 for female. That's the grouping code or our code for male and our code for female. Then continue. Then after setting the test variable and the grouping variable, after defining the variable into 1 as male, then 2 as female, you click on OK. So wait for a second. So this is our t-test generated value. So in terms of age, we have here sex, male then female, our N 33 for males, 231 for females, and then mean for male 22.67, female we have 31.81. Then the standard deviation is also given as well as the standard error. I discussed already standard error in our class. Then looking at the independent sample t-test, under t-test we have equal variances assumed that first, the variances between male and female are assumed to be equal. And then the second assumption is that the variances between male and female are not equal. Then we have here the SIG, this refer to the significance level. So we have the significance level, 0.000. And we call this one as our p-value. And we have our t, so we have negative 0.6585. The other one for equal variances, so we have negative 0.6585. And for the equal variances not assumed, negative 15.175. Then we have also the test for equality of means. So we have significant levels. So we have 2 tilde 0.00. And for not equal variances being assumed, still 0.00. Mean difference, so we have negative 9.143. The other one negative 9.143. And then we have the standard error. I discussed already the meaning of standard error. I discussed also the 95% confidence level for the difference. So we have the lower limit and the upper limit. I discussed how to get this one last time. So kindly remember my discussion about this. So we look at into the alternative hypothesis because we have here one-tailed and we have two-tailed. So we have to call a one-tailed and then a two-tailed test. Remember that the determination for one-tailed and two-tailed is actually based on how you formulated the alternative hypothesis. So let's go back to the alternative hypothesis. I mentioned that the alternative hypothesis is there is a significant difference of the ages of the respondents when grouped according to sex. So when we look at there is a significant difference, then we can say that the age of the female is not the same to the age of the male respondents, or the age of the male respondents is not equal to the age of the female respondents. So there is what we call not equal in the condition. If the symbol being used is not equal to, then that means that it can be male ages are older than the female ages, or it can be the female ages are older than the male ages. So there are two possibilities. So we call that one for two-tailed. That is why in terms of the p-value, we look at into this column here, sig two-tailed, because our alternative hypothesis calls for a two-tailed test. So our p-value is actually referring to 0.00 for both equal variances assumed and equal variances not assumed. And then this sig in here is also for the equality of variances. This one, equality of the means. So when we look at into the equality of the means, we look at the mean of the ages of the female respondents, and then the mean of the ages of the male respondents. We look at into the significant difference of the ages of the male and female respondents. You look at into this t-test for equality of means. But since we define that our n is greater than 30, in this case, our n is, we have 33 for males, then female, we have n is 231. If we're going to add, the total is 264, our n is greater than 30. So we just change instead of t-test, so we have to consider this one as z-test. The computation is the same, but you are going to make use of a change of the symbol to be used and the name of the statistical test. So instead of using t-test, we have to make use of z-test. So the next one, we're going to compare the value. So we have to compare the p-value, and the alpha value. So the p-value and the alpha value. So there are two assumptions, equal variances. So if we assume that there is an equality of the variances between male and female ages, then we have to make use of equal variances assumed. So we have 0.000. So this is our p-value, and our alpha is equal to 0.05. So we have to compare the p-value and alpha. So 0.00 is actually less than 0.05, less than 0.05. So we're going to reject HO. We're going to reject HO. If we reject HO, then we actually accept the alternative hypothesis. And when we accept the alternative hypothesis, it means that there is a significant difference. There is a significant difference of the ages of the respondents when grouped according to sex. There is a significant difference. There is a significant difference of the ages of the respondents when grouped according to sex. If you look at equal variances not assumed, so we're going to have an assumption that the variances equality of the variances are not being assumed. Then still 0.00 as our p-value. So we compare the p-value to the alpha value. So 0.005 is still less than, 0.001 is less than 0.05. So our p-value 0.00, our alpha is 0.05, so 0.001 is less than 0.05. If the p-value is less than the alpha value, we reject HO. If we reject HO, it means that the acceptance of the alternative hypothesis. So our alternative hypothesis, there is a significant difference of the ages of the respondents when grouped according to sex. Again, there is a significant difference of the ages of the respondents when grouped according to sex. So that's how you are going to apply SPSS in the computation of t-test or z-test. So if the n is less than, if the n is less than 30, or some books say less than or equal to 30, then use t-test. So follow the naming of the generated value for t-test. However, if n is greater than 30, some books will say n is greater than or equal to 30, make use of z-test. So the symbol there will just be changed in terms of the z-test. So take note, in this case, we change t to z because our n is 264 and that n is greater than 30. Now, we look into the discussion last time about the template. If you reject HO, the claim is HO. There is a significant, you're going to say there is enough evidence to reject the claim. If the claim is HO and then you reject HO, then you're going to say there is enough evidence to reject the claim. However, if the claim is HA, you reject HO, then you're going to say there is enough evidence to support the claim. Now, if you fail to reject HO, then the claim is HO, you're going to say there is not enough evidence to reject the claim. And if the claim is the alternative hypothesis and then you fail to reject HO, then the template is there is not enough evidence to support the claim. So let's go back to the problem, applying that one to what we have mentioned in the template of making an analysis and interpretation. So from the given problem, it is mentioned, is there a significant difference of the ages of the respondents when grouped according to sex? So the claim is all about having a significant difference. So the claim is towards the alternative hypothesis because it is mentioned, is there a significant difference of the ages of the respondents when grouped according to sex? So the claim is towards what? Alternative hypothesis, that there is a significant difference. Analyzing the tenor of the question. So our claim is the alternative hypothesis, and then we reject what? We reject HO. So according to the template, if the claim is HA and then we reject HO, there is enough evidence to support the claim. To the template, there is enough evidence to support the claim. So what is the claim? That there is a significant difference of the ages of the respondents when grouped according to sex. So finally, we could say there is enough evidence to support the claim that the ages of the respondents are different when grouped according to sex. So there is enough evidence to support the claim that the ages of the respondents are having difference when grouped according to sex. And since there is a significant difference, if these 264 are randomly selected from the total population, then we could say that the significant difference of the ages in the sample 264, this result can be generalized also to the total population where the 264 is actually taken. So I repeat, if the result is a significant difference, that means that it is actually found in the sample. In this case, the sample is 264, and that can be generalized also to the population where the sample 264 are actually taken. So under this case, if there is a significant difference of the ages of the respondents when grouped according to sex based on the 264 sample, then this can be generalized to the entire population where the sample is actually taken, where the 264 is actually taken. And we could say that if it is true in the 264 sample that there is a significant difference of the ages of the respondents when grouped according to sex, it can be concluded also, it can be generalized also to the entire population. That in the entire population where the sample is actually taken, there's also a difference of the ages of the respondents when categorized, when grouped according to sex. So, as an exercise, I want you to look at into this category. So I'll go back to the data. I'll go back to, hold on, for example, I go to the this this one. So I want you to look at into weight and height. No? So the exercise, is there a significant difference of the heights of the respondents when grouped according to sex? Is there a significant difference of the heights of the respondents when grouped according to sex? The number two classwork, is there a significant difference of the weights of the respondents when grouped according to sex? I repeat, number one classwork, is there a significant difference of the heights of the respondents when grouped according to sex? Number two, is there a significant difference of the weights of the respondents when grouped according to sex? So that's the classwork. So review the entire video and then do the classwork.